In this talk, I'm going to cover Agentic 101. This is the basic level overview of Agentic AI. There is a lot of buzz in the market and in the industry about Agentic AI. I just wanted to ground everyone what is Agentic AI and go through some basics and some notes that I had prepared based on my own research. So what I will cover today is this is the agenda for my talk. So we'll cover what is agency is, we'll go through key vocabulary definition as to what frameworks, libraries, SDKs, and protocols are. We'll cover MCP and A2A protocols, and then we'll take a deep dive at a high level what MCP is and what A2A is. We'll compare A2A with MCP, how they fit together, and I'll also share a technology roster of list of agentic technologies that I have researched, but there are quite many, but these are selective few that I have identified. And we'll go through a framework of when to use agents and not to use agents, and also a decision tree that I created for myself. So with that, let's cover what is agency. So the dictionary definition of agency is the capacity of individuals or things to act independently and make their own free choices. So it's a self-directed action, not a passive code. Agency means, in terms of agentic AI, it's a loop like sense, decide, act, learn within the goal boundary. So the system is in a loop to continuously achieve a goal, like a Roomba pathfinding robot which looks for to clean up your home, or an auto trader bot which tries to maximize the profit, or a triage chat bot which tries to find a right place for patient to navigate. In AI, what an agent is, whenever you say it's an agent, it's a code, memory, model plus some set of tools that we'll cover what tools are. And then we'll get into, in contrast to a traditional software, you have a script which just obeys what you have designed it for. But agents chooses its own next steps and make decisions to achieve a goal. So why do we care? It removes manual hops, it scales the expertise and reacts in real time. Real time in the sense, like it may not be as real time as a real time software, but it's making its own decision and taking the steps. We'll get through some little nuances later. Guardrails is an anarchy. And so you need to make sure that your agentic system has guardrails in terms of scope, metrics, and a kill switch or a human oversight. That's one of the important aspects. So there's a lot of buzz around everything is AI and agentic, like everything is agentic currently. Everybody is saying they're creating agents, but we need to think in terms of what do they mean by agent and agentic AI. I want to make a distinction between AI workflow, agentic AI. When we are thinking about a workflow, we have a concept of we reason and we act as humans. So say you want to write an article for LinkedIn. The way you will write that article is you'll go through set of articles, you'll read them, you'll summarize those in your own notes, and you will write a post. So the same thing can be delegated with an AI workflow where you compile the links and give it to an AI chatbot or chatbot that can read those articles, summarize using, say, Perplexity, and then write a code, write a post using Claude. So you see multiple things that are stringed together. That's a workflow. So you have a manual workflow, but you are automating it through an AI workflow. That I will call it as AI workflow. And also we have seen evolution of these different chatbots, like that's LLM. So since ChatGPT was launched, we have seen ChatGPT, Claude, Gemini. So these kind of chatbots, so that's static knowledge that you're extracting. These chatbots have become advanced now. They also have agentic systems in place, but at a high level, it's all information retrieval. Then we saw a couple of rack systems, which is retrieval augmented generation, where you're providing contextual knowledge within your own company or within your own domain and asking the chatbot to make sense out of it, summarize it. So those were the systems that we designed in last 2 years. But now we are entering the agentic AI. So not just information and knowledge, you are using agents to take decisions and act and do. So that's where the agentic AI is. It's like, hey, I want to take a vacation. I want to go to Singapore, and you may go to ChatGPT and prepare your itinerary, but ChatGPT won't book your hotel. But if there is an agentic AI system, it can not just give you the itinerary, but find a nearest hotel according to your budget, make your reservation, do airline reservations and everything at a one-stop shop. So that can be an agentic AI system. So that's just one example of agentic AI. So we are moving from just information and knowledge to action and for the benefits of user. So we are reducing the burden that user has to go through to digest that knowledge that these previous AI systems did. They did help us, but they didn't really do the job. So they didn't look up a hotel, they checked the star rating, or the burden was on you. But now these new agent systems are doing the job on their own. So the other aspect is, let's again hash and hammer the concept of LLMs versus AI workflow versus agentic AI. LLMs is like a single building block. You generate content, but you decide if it's useful or not. So the human is in loop. It needs prompt. It doesn't have a concept of memory, but these current ChatGPT model or Claude do manage memory these days. So you give a prompt and you get an answer. It's all information and knowledge that's getting retrieved. An AI workflow is amplifying that thing to the next level, where you're creating these chain of prompts and chain of steps to say you want to write an article, you summarize it and you write an article, and it's producing that output. It's chain of tasks string together using LLMs and tools to give you an output. But again, the human is putting together those steps. It knows what step to take one after other. So human is involved. So it just follows the steps that you provided. And agentic AI, again, it's an autonomous system within the goal boundary. It breaks down the tasks, understands what tools it needs to use, adapts a plan, and achieves the goal. So it thinks, acts, iterates towards a success with minimal input. So again, it has concept of memory, tools, decision, and it also has decision-making ability. Couple of agentic systems that we have seen is Copilot, GitHub Copilot, coding agent, Cursor, the coding agent famous, and the Claude code agent. So these are the agentic systems which are used currently within the software. But they go beyond they just don't provide the information. They understand your code. They write like thousands of lines of code, and they assist the software engineer to achieve or to program. Other buzzword is AI agents versus agentic AI. When you think about AI agents, it's like a single agent. AI agent is a single agent, say, for example, a thermostat whose goal is to keep the temperature at 21 degrees C or at 70 Fahrenheit. So it's one job. AI agent is a single thing just acting within to achieve one thing, versus agentic AI is a set of AI agents working towards a bigger, higher goal. Think about it as like bunch of robots that work together. So it may be a thermostat which teams up with a weather bot to check the weather and accordingly adjust the weather. Energy prices, so we can decide. Energy bot can help to give when the energy costs are low and high, then decide whether a system needs to be turned on and off, or you can go by your own schedule. So these things are working together to heat up or cool your home efficiently. So one acts alone, which is AI agents, and agentic AI is set of AI agents collaborate to solve a bigger multi-step problem. So that's the idea of AI agents versus agentic AI. Now let's ground ourselves with the concept of library, framework, protocol, and SDK. A library is nothing but a toolbox, which is a set of functions or library. It gives you maximum freedom, but it has low structure. So you are creating the framework and you are designing that program. A framework is opinionated. It provides maximum guidance, but still it has low structure. It's a blueprint that calls you. And a protocol is like traffic laws that govern the communication. So it's low structure, low control. It's just traffic laws and the rules of communication between different systems. Whereas SDKs are often combination of libraries and framework from a specific provider, say Microsoft, OpenAI, or Google. So it's one-stop shop to achieve certain things. So you can build faster for one platform. So the control axis versus, so I try to put these together into these two-dimensional chart where your control axis is on the left and your x-axis is your structure. So as SDKs often bundle and libraries and frameworks, as I'm repeating it again. So you can build faster for one platform, but you're locked towards one platform. MCP, Model Context Protocol. This was launched, I believe it was November of last year. So the purpose of MCP is Model Context Protocol. It's one standard plug for tools and data. So think about it as a USB hub for your computer, where think about your computer as LLMs and you're giving access to your own personal data through these different MCP servers. So your MCP client, so the LLM acts as a client and the server is your different tools and your data. So it can be your Slack or a Gmail or your calendar that is getting plugged to the brain, which is your LLMs. So those become your MCP hosts and your servers are these different tools. They work with remote APIs. So on the steroid, you just tell that, hey, if I want to interact with my team, I use Slack. And if you want to communicate with anyone, use this tool. So that's how you're plugging in that ability and instructing the LLM on when to use that specific web server through the API schema that you define as part of the MCP protocol. So it helps you define that schema. It helps you interact with LLMs, and you're plugging in different tools and data to your LLM. Then came A2A, that was launched by Google. I believe that was April or March or April 2024. It allows you, once now you're creating these agents may span across multiple systems. So this is the protocol again, which is how you communicate with these different agents. So they use A2A protocol. It has a concept of agent card, which advertises skills in terms of JSON, and they negotiate the tasks. It acts discovery, delegation, and shared state management. It works with MCP also, so it complements MCP. So A2A passes baton to MCP to fetch the tool. So these are not competing protocols, but they work in consensus. So these are open protocols again. So in case of an healthcare example would be the triage agent, which hands off to a billing agent across a hospital payer boundary. So that's one example. So A2A is digital handshake. Agent meets, swap credentials, delegates work, pairs up with MCP. So each agent keeps its own tool belt. So it's about agents. These are autonomous to think of like humans, or they are taking some task, versus MCP is about the tool belt that goes on that agent. So we can think about it like a plumber. The plumber comes with a tool belt and he knows what tool to use when by getting the right tool from his tool belt. So MCP is your tool belt and agent is your plumber. So that's how you think about A2A and MCP. Handles who and how to talk to another agent. MCP is what they use once they are connected. So together, smooth handoff and plug and play tools. So I won't repeat the example. You can see where these protocols fit. You have an MCP host, which is a bunch of MCP clients. They connect to another agent and they coordinate amongst different agents via A2A protocol. And if that agent is talking to the tools, they use MCP. So that's the distinction. And again, let's reiterate. Agent to agent, A2A, MCP is agent to tools and data. So discovery, delegation, and state sharing is on A2A side. MCP provides a unified API schema to connect to your data and to your tools. And it's a level of abstraction that exists. So you use agents and when to skip agents. So whenever there are multi-steps, a dynamic flow, then think about bringing in agents. So you don't know what steps to take. You know these are the set of steps, such as online return, restock, refund, or customer email. So these are different things that may happen for a specific customer complaint. So you may take those steps together. So it's multi-step, dynamic flow, then use agent. Whereas if there is a single deterministic task, like say MRN lookup, it's a simple regex check. So that's where you skip the agent. Context changes at each case. So if the context is changing when you're taking each step, then try to bring in the agents. And if you need latency, if speed is the concern, that's when you skip the agent, because say you're building a patient monitor and your alert needs to happen within certain time constraint. You don't want to bring in an agent which goes to an LLM that takes a minute to think. So you don't want to bring in there. So that's that's one example where time constraints doesn't make sense to bring in an agent. You need to delegate and you need to use tools, lead qualification, creating CRM records, scheduling meetings, post recap to a Slack. So that's one example. Rigid rules, if there are rigid rules that are already coded that you need to follow, then you don't want to bring in the agents. You want to avoid hallucinations and wrong steps. So CDC vaccine schedule lookup is one example. The other example is learn via feedback loops. So if the system needs to learn, then you bring in agents. So, and you skip the agent if there is like regulatory risk, or it's better be static. So if insulin pump firmware and all, so you don't want to bring in an agent. So the golden rule is when tasks are dynamic, context heavy, require tool orchestration, use an agent. When it's fixed rule, needs sub-second, millisecond latency, or if there are time constraints, has safety or regulatory constraints, keep it static software, skip the agent. So a couple of technologies to see how they fit together. So I put this chart at a high level, your protocols, you should stick to protocols. That's the standard way of operating. So you should adapt MCP and A2A where they fit together. This is in the order. If I'm building an agentic system, this is what I would use. Crew.ai, simple multi-agent orchestration. If you have multiple steps, just go with it. It gets you started quickly. LangChain and LangGraph are another popular frameworks to build agentic system, where you don't want to tie to one specific vendor, such as OpenAI or Gemini or Google. So you can use one agentic platform framework. So you will go with LangGraph. OpenAI Agent SDK, I have played with it. It is proprietary, so you're locking down to OpenAI. It makes working with OpenAI easier. It gets you faster, but you're tied to OpenAI. You can bring in other agents, but still, if 80% of the work needs to happen with OpenAI, use Agent SDK. Google ADK is another similar. So if most of the work needs to happen with Google Agent SDK, try to use Google Agent SDK. But I think they have become very popular with A2A adaptation because an MCP adaptation. So that's also another one which is gaining popular. AutoGen, Super AGI, Semantic Kernel. These are other examples of another agentic workflow. And in terms of platforms, EPAM Dial is another open source platform that allows you to build agentic system. So that's also another platform. So these were my list of technology roster that I have seen, but there are more. Everybody is doing agents and agentic workflows. There is UiPath, there is end-to-end. Everybody is saying these are agent, but end-to-end UiPath, it's more towards AI workflows and not true agentic systems. So that's one example. And the other cheat sheet that I have is when to use agent versus not agent. If it's a single agent and it requires tools, go with MCP, LangChain, and LangGraph. If LangGraph, if required. If you are working with OpenAI, pick their OpenAI SDK. If it's just like LangChain, if it's not an agentic system or a single, you can even build it using LangChain. Multi-agent, if you are using multi-agent, conversation style, if it's conversation style chatbot, use AutoGen. Simple role, if there is a simple role or a team, you need a fast POC, adapt crew.ai. If there is a complex graph and state and a memory management, LangGraph gives you complete control. Google SDK has done a good job. You can mix and match these tools, so there is no one tool as such. You can combine all of them together to delegate to the right framework or a right library or SDK based on the agentic system. If you're using .NET, Semantic Kernel is another option within the Azure ecosystem. Want open source version and want a GUI, then Super AGI is another one. Offline also there is Hugging Face Transformer Agents is another one. So that was my talk. This was just my notes that I wanted to share with you. I hope you enjoyed the talk. So this is the demystification of the agentic ecosystem. So give me feedback and let me know if you like to see many of these videos, such videos.